Hi, thank you for coming to my talk. I'd like to thank the organizers for giving me the opportunity to speak. So I'll be talking about a project that is in progress. It's about constructing and computing invariants of Legendrian spheres in the standard contact spheres. So the standard contact structure on S5 can be thought of as being induced by the convex boundary of the standard symplectic six-dimensional ball. It's induced as being transverse to this Liouville vector field. It's supported by an open book decomposition, which has the four ball as pages, which have the standard symplectic structure on them, and the monodromy is the identity, and S3 is the binding of that open book. So we'll talk about different ways of constructing Legendrian spheres in this contact sphere. And so one way to do that is you consider a Lagrangian slice knot in the binding S3, which has the standard contact structure in it. And suppose dk is a decomposable disk that the Lagrangian slice knot bounds. Given that, the way you can construct a Legendrian sphere is you can stabilize the open book along K, and the way it changes the monodromy is to every page it adds a two handle along K, and the monodromy is changed by a Dane twist about the resulting Lagrangian sphere in the book. Okay, so now that gives you a Lagrangian sphere that lives in the book of the open book. And what you can do is you can perturb this Lagrangian sphere, which means you can sort of push it up, down in some way. And that can be perturbed to give you a Lagrangian in the standard contact sphere. So we'll call that the stabilization sphere of dk, or S stab dk. Okay. So to compute invariance for these spheres, we'll consider another construction of Lagrangian spheres from dk. So we already saw how to construct the stabilizing sphere from dk, S stab dk. So the other one we'll call S join dk. And the way you can get that is consider the open book as described before with the four ball page and the identity monodromy, and take two copies of the Lagrangian disks in the open book, and you can sort of join them. There's some subtleties there, but you can join them. Since these Lagrangians are disks, you can join them and perturb them to be Lagrangians. And we'll call this Lagrangian sphere S join of dk. So what allows us to compute invariance is the first step to that is the fact that these two Lagrangian spheres are actually isotopic. And it actually follows from a more general statement. So if you have an odd dimensional contact manifold, which is supported by an open book, the pages are exact symplectic manifolds, sigma and the monodromy is phi, and L is some Lagrangian disk in the page that is arbitrarily close to the boundary of the page or the binding of the open book. In that case, we can define a stabilizing sphere from L and the join of L's in different copies similarly as before. And we can show that these two are in fact isotopic. And in the previous case, then follows. So now, the way this proof goes, there's really two main ideas here. The first one, which is a simple idea, but it's sort of technical to show, is that we want to interpret stabilizing as an embedded operation. So we want to, stabilizing is usually seen as an abstract operation where you have a stabilized open book and you have a normal open book and they're shown to be contactomorphic. Here we want to see it as really the same operation that allows us to see these two Legendrians in the same manifold, which after that we can talk about actually constructing an isotopy between them. And so the idea to show stabilizing as an embedded operation, it's generalizing an idea of Vertessian Licata in 3 dimensions. And we essentially show that stabilizing is the same as removing and regluing a codimension 0 ball. Okay. So once we do that, we can interpret the monodromy Dane twist as a Legendrian surgery, and then you can isotope sort of the core of the two handle across the surgery torus to the disc, and that allows us to construct the isotopy between these two Legendrians. So once we get the S-joint Legendrian, what we can do to help us compute invariance is we can remove a point from the binding, and that allows us to bring it into Euclidean space, R5, and with some perturbation and using the fact that it's a decomposable disk, we can get its front projection for the disk. And once we have the front projection of a sphere, it's sort of shown as this movie. We can use ideas of Ekholm to compute its Legendrian contact homology invariance. Okay. Legendrian contact homology was defined by Chekhanov and Ilyashberg in 3 dimensions and generalized to higher dimensions by Ekholm, Etnar, and Sullivan. So once we can compute these invariants, we're actually able to show that this gives an infinite family of Legendrians in 5 dimensions. So we show that the stabilizing spheres corresponding to these particular disks, if you keep adding twists along here, they're all pairwise non-isotopic and so that gives us an infinite family of Legendrian spheres in the standard contact sphere. All right, so thank you for listening, and please do let me know if you have any questions.